The cotangent function is the reciprocal of the tangent function, and before we graph it, let's take a look at the unit circle. By definition, cotangent of an angle theta equals x divided by y. So to find the value of the cotangent at each of these points on the unit circle, we need to divide x by y. For example, let's find the value of cotangent at 0. Here 1 divided by 0 is undefined. So we can write that cotangent of 0 equals 1 divided by 0, which is undefined. Now let's try another angle, for example pi over 4. At this point, both x and y are square root of 2 over 2, so when we divide x by y, we will get 1. Then we can write that cotangent of pi over 4 equals square root of 2 over 2 divided by square root of 2 over 2, which makes 1. At pi over 2, 0 divided by 1 is 0. So cotangent of pi over 2 equals 0 divided by 1, which is 0. Now in quadrant 2 at 3 pi over 4, negative square root of 2 over 2 divided by positive square root of 2 over 2 equals negative 1. So we will write that cotangent of 3 pi over 4 equals negative square root of 2 over 2 divided by positive square root of 2 over 2, which makes negative 1. And now let's have one more value of the cotangent function at pi. Here, negative 1 divided by 0 is again undefined. And let's write that cotangent of pi equals negative 1 divided by 0, which is undefined. Now I will have the rectangular coordinate system to the right, and we will start the graph of the cotangent function. On the x-axis, we will plot 0, pi over 4, pi over 2, 3 pi over 4, and pi. So here we have them, together with a few values to the left of the origin. Now let's see the behavior of this function from 0 to pi. We know that at 0 and at pi, the function is undefined. At these two values, we will draw two vertical asymptotes. Here they are, and I made them dotted because they are not part of the graph of the cotangent function. At pi over 4, the value of the cotangent is 1, so on the graph we will have a point with the coordinates pi over 4 and 1. At pi over 2, the value of the cotangent is 0. And at 3 pi over 4, the value of the cotangent is negative 1. So here we have the 3 points, and now we will connect them to get the graph. Notice that as we get closer to 0, the function will approach positive infinity, but when we get closer to pi, the function approaches negative infinity. So let's connect the points, and we will have the graph of the function over one period on the interval from 0 to pi. And because the distance between two consecutive asymptotes is pi, we say that the period of this function is pi. Now this graph will repeat itself to the left and to the right indefinitely. I will repeat this graph over a few more periods, and then we will talk about the properties of this function. So here we have the graph, and now let's talk about the first property. The period of this function is pi, and we can write that cotangent of any number n plus pi equals cotangent of this number n. For example, let n be pi over 4, then cotangent at pi over 4 is 1. And now if we take pi over 4 and we add pi, we will get 5 pi over 4, and at 5 pi over 4, the value of the cotangent is also 1. The next property will be about the domain of this function. The domain is all real numbers except integral multiples of pi. For example, the function is not defined at 0, or pi, or 2 pi, and so on. And as you see, at these points, we will have vertical asymptotes. Now, the range of the function is all real numbers. This means that the function stretches up and down indefinitely. The vertical asymptotes occur at any integral multiples of pi, and these are the numbers where the function is not defined. The cotangent function has an infinite amount of vertical asymptotes, however, it does not have any horizontal asymptotes. Now, let's talk about the x-intercepts. These are the points where the graph crosses the x-axis, and they occur right in the middle between two consecutive asymptotes. And as we said earlier, if from the x-intercept we move halfway to the right between the x-intercept and the vertical asymptote, the value of the function is -1, and if we move halfway to the left, the value of the function is +1. The cotangent function is an odd function, and this tells us that the graph is symmetric about the origin. This means that cotangent of -x equals negative cotangent of x. For example, if we look at the graph, cotangent of pi over 4 is 1, but cotangent of negative pi over 4 is -1. So we can say that cotangent of negative pi over 4 is equal to negative cotangent of positive pi over 4. So again, cotangent of negative pi over 4 is -1, but cotangent of positive pi over 4 is +1, and with the negative in front will also be -1. And now the last property here is that the cotangent function is decreasing on every interval between two consecutive asymptotes. So if we look at the graph between two consecutive asymptotes, as we move from left to right, the graph goes down. This is all I wanted to show you in this video. I hope you enjoyed it. Please subscribe, leave a comment, and thank you for watching.